Hi everyone, we're on to the second page for lesson 3. We're still working with compound interest for one more problem. As you can see, I've rewritten the compound interest formula at the top here. This one is going to be a comparison. So we have Catherine invested $750 in an account paying an interest rate of 6 5/8% compounded annually. Hunter invested $750, so the same amount, in an account paying an interest rate of 6.5% compounded monthly. After 18 years, who would have more money in their account and how much more to the nearest dollar? So we have two accounts. We have Catherine and we have Hunter. So we need to run this compound interest formula for both of their scenarios. So let's start with Catherine first. So Catherine, we have a starting amount of $750. We have a rate. Now, this 5/8 I'm going to convert to a decimal because nobody's got time for fractions. So this is going to be 6.625%, which is 0.0625. N compounded annually is 1, and then T is 18 years. So we have A is equal to 750 times 1 plus 0.0625 over 1 times 18 times 1. So 750 times 1.0625 to the 18. So let's calculate that out. And we get $2,233. They did say nearest dollar, so that's where we're going to stop. So there is Catherine's amount after 18 years. We're now going to do the same for Hunter. For Hunter, he also started with $750. His rate was 6.5, so 6.5%, which is 0.065. His N, he's monthly, so that's going to be 12, and time is still the same, 18. So now we're going to run compound interest formula for Hunter. So A is equal to 750, 1 plus 0.065 over 12 to 12 times 18. All right. Let's do a little bit of simplifying to help us out. So we have 1.00542. All right. And we get for Hunter's total $2,409. So we have now run the calculations for both Catherine and Hunter. So the question is, who would have more in their account and how much more to the nearest dollar? Well, from our calculations, Hunter comes out on top. He got more money, 2,409 compared to 2,233. So now we just need to calculate the difference. 2,409 minus 2,233. So the difference would be $176 difference. All right, and so that is compound interest. Now we need to look at one more formula, and this is called the continuously compounded interest. So we're still compounding interest. It's just now continuously, like it's always happening. So here's our formula. A equals P E R T. You will also hear it referenced as the PERT formula. So if you hear me say PERT, or you hear, anywhere else refer to it as PERT, this is why it kind of spells out PERT. So A, that is still our ending amount. P is our starting amount. All right, E is called the natural base, but it's just a number. And I will point out the number on a calculator where to find it. It's kind of in the same vein as pi. R is our rate as a decimal, and T is time in years. So here we have Jose invested $8,300 in an account, paying an interest rate of 6.6% compounded continuously. Assuming no deposits or withdrawals, how much money to the nearest dollar would be in the account after 14 years? So our starting amount is $8,300. Our rate is 6.6%, which is 0.066. And our T is 14 years. So we have A is equal to 8,300 E to 0.066 times 14. This one, we only need to simplify the exponent. So 8,300 E, so 0.066 times 14 is 0.924. All right, so now let's talk about this E button. Normally, it's around the pi button. As you can see, it's actually the same as my pi button here, but you're looking for that E, and it'll look kind of fancy in there. So we have the E, and then we put our exponent, which was 0.924, and we get $20,911, because again, they said to round to the nearest dollar. If you are using, say, Desmos, you just need to open up, the keyboard, and there should be an E button in the functions. All right, now we're going to work backwards. Natasha is going to invest in an account paying a rate of 5.5% compounded continuously. How much would Natasha need to invest to the nearest $100 for the value of the account to reach $1,400 in 16 years? So we have a ending amount of $1,400, a rate of 5.5%, which would be 0.055, and the number of years as 16. So we have 1,400 is equal to P E to the 0.055 times 16. I'm going to simplify the exponent, 0.055 times 16. That is 0.88. And then all we have to do, divide both sides by E to the 0.88 power. So 1,400 divided by E to the power of 0.88. And we get $580, But since they want us to round to the nearest 100, we're going to round up to $600. So there we go. All right, one more problem, and this is another comparing one. So we have Aubrey invested $910 in an account. So we have Aubrey. Her principal amount is $910, and then her rate 3 7/8. Again, nobody's got time for fractions, so convert it to a decimal. And I'm just going to convert it from a percentage to a decimal right away here. So 0.03875. And then it's compounded continuously. So we don't need an N, but we will need a T, and we'll get that here at the end. And then we have Abigail. Also invested her starting amount of $910. Interest rate of 4 1/8. Again, no one's got time for decimals. So 0.04125. And this is compounded monthly. So Abigail is going to have an N. So it's monthly, so 12. After 20 years, so there's our T value for both of them. How much more money would Abigail have in her account than Aubrey to the nearest dollar? So Aubrey is going to be using the continuous compounded interest formula, so the PERT formula. Abigail is going to use the original compound interest formula. So, Aubrey, sorry, excuse my dog's barking. So, Aubrey, A is equal to 910, E to the 0.03875 times 20. So, 910, E to the 0.03875 times 20. So that's going to be 0.775. And so nearest dollar, we have $1,975. Now it's time for Abigail, just doing compound interest. So we have A is equal to 910, 1 plus 0.04125 all over 12 to the 12 times 20. So 910. So let's simplify this. So we have 1.00344. 12 times 20 is 240. And then now we just have to plug this all into our calculator. Times 910. And we get $2,074. So Abigail has the most amount of money. So now we need to know the difference. So 2,074 minus 1975. And it is a $99 difference. Phew, sorry for how long these notes are, but as long as you can plug stuff into a formula, you should be good to go. And that ends lesson 3.